In this video, we're going to show that the Taylor series for sine of x is actually equal to sine of x. And to do so, we need to use Taylor's error estimate, sometimes called the Lagrange error bound, which says that the difference between the nth degree polynomial and the function evaluated at a point is no more than m times c minus a to the n plus 1 over n plus 1 factorial on a to c, where m is the maximum of the n plus first derivative. So let's see how this is going to play out. First off, we're looking in general, so the nth degree Taylor polynomial of sine of x, just evaluated at x, minus sine of x, is going to be less than or equal to something here. Now we're centering this one at 0, so a is going to be 0. So this is going to be x to the n plus 1, the absolute value of x, over n plus 1 factorial. And the only thing I need is that m value here. Well, m is the maximum of the n plus first derivative. Well, if our function is sine x, the derivative is cosine x, the second derivative is negative sine x, third derivative is a negative cosine x. And then we're going to start this cycle again. The fourth derivative is going back to being sine x. Now, because of this nature, all of these are less than or equal to 1 on the domain of all reals. What that's going to do is that's going to allow me to choose m to be 1. So I'm just going to put in a 1 there for m, which greatly simplifies this. Now, what we need to look at is what happens as n gets infinitely large, because we're taking the infinite Taylor series. So we need to look at the limit as n goes to infinity of the absolute value of x to the n plus 1 over n plus 1 factorial. We need to figure out what this limit is. Now, here's what we're going to do to help us out. We're going to use something we already know. And that is, we know something about this particular Taylor series, x to the k over k factorial from k equals 0 to infinity. This is our Taylor series for e to the x. Turns out this Taylor series has an interval of convergence of negative infinity to infinity. I've done that in another video, so I'm going to use that piece of information here. Well, what that means is I have a convergent series, and if it's a convergent series, then from what we know of series, x to the k over k factorial must go to 0 as k goes to infinity. Right? The sequence piece must go to 0 if the series converges. Look at the form here, x to the k over k factorial. Basically let k equal n plus 1. We've essentially got the same thing. So we're using this to show that this equals 0. What that shows me is n goes to infinity of the nth degree Taylor polynomial, or our partial sum, x equals 0. That means our infinite Taylor series is exactly equal to sine of x. So this is how you can show that a series converges to its generating function. You must show that its error bound, it's from Lagrange, goes to 0 as n goes to infinity.